The formula has never been patented. It has never been published. It has never been independently verified by any public laboratory or shared with any regulatory body beyond the minimum required by law. The company that makes it does not employ chemists to improve it. They do not run research and development programs to refine it. They have not changed it in any meaningful way since 1953. The formula sits in a vault known to a small number of people, and the company intends to keep it that way indefinitely. This is not a pharmaceutical compound worth billions in intellectual property. This is a spray can that costs $5.99 at any hardware store in the world. It smells like a mechanic's shop. It leaves a faint, oily residue on everything it touches. It has no single defined purpose. The label lists corrosion protection, lubrication, moisture displacement, and penetration of stuck parts as its primary functions, which means it does 4 different things adequately rather than one thing perfectly. And the world has decided this is exactly what it needs. 2000. That is the number of documented uses that WD-40's manufacturer has collected from customers over the decades. 2,000 specific applications for a single product: loosening rusted bolts, removing adhesive residue from surfaces, protecting leather, cleaning crayon from walls, freeing stuck zippers, silencing squeaking hinges, removing rust from fishing hooks, coating saw blades before cutting through sap-heavy wood, keeping snow from sticking to a shovel blade, displacing moisture from flooded engines, deterring pigeons from roosting on ledges. The list is not marketing fiction. It is the accumulated testimony of people who ran out of the correct specialized product and reached for the blue and yellow can and discovered, to their satisfaction, that it worked. None of this was planned. This is the story of how Norm Larson, a chemist working in a small laboratory in San Diego, California, makes 40 attempts trying to solve a single very specific aerospace engineering problem, succeeds on the 40th try, produces a formula he names with mathematical simplicity after his own failure count, and accidentally creates a product that ends up in over 176 countries and generates roughly $500 million in annual revenue for a company that manufactures almost nothing itself, patents nothing, and has spent 7 decades selling essentially one product in an aerosol can. The problem Larson is trying to solve in 1953 is not a garage problem. It is a missile problem. The Convair Corporation, a San Diego aerospace manufacturer working under contract for the United States Air Force, is developing the Atlas intercontinental ballistic missile. The Atlas is a significant engineering achievement and a significant engineering headache. Its airframe is constructed from extremely thin stainless steel, kept rigid not by the thickness of the metal itself but by internal pressurization, like a balloon made of steel. This is innovative and weight-efficient and catastrophically vulnerable to one thing: moisture. Condensation on the skin of an Atlas missile begins the process of corrosion that can compromise the structural integrity of a pressurized vessel. A corroded Atlas missile is not a strategic deterrent. It is an expensive failure waiting to occur on the launch pad. Convair needs a compound that displaces water from metal surfaces, prevents corrosion, and can be applied quickly and evenly across large aerospace components. They contract the Rocket Chemical Company, a small San Diego firm, to develop it. Norm Larson is the chemist assigned to the project. He attempts a formula. It does not perform adequately. He attempts another, then another. He adjusts the solvent ratios, the oil composition, the carrier chemistry. He attempts the formula 39 times, and does not achieve the required performance characteristics. On the 40th attempt, he does. He names it water displacement, 40th formula, WD-40. The compound works. Conveyor applies it to Atlas missile components. The corrosion problem is addressed. The project closes. The Rocket Chemical Company has a formula, a small production capability, and a contract that has concluded. Then the conveyor workers take the cans home. This is the specific mechanism by which WD-40 leaves the aerospace industry and enters the world. Workers at the conveyor plant, familiar with the spray from their work on the Atlas program, begin removing cans from the facility for personal use. A product designed to protect intercontinental ballistic missiles turns out to work extremely well on squeaky hinges, stuck bolts, and rusted garden tools. The performance characteristics that make it useful in aerospace, water displacement, penetration of tight tolerances, light lubrication, and corrosion inhibition also make it equally useful in a garage, a kitchen, or a workshop. The workers know this because they test it in their own homes and confirm it with their own hands. The Rocket Chemical Company notices. In 1958, 5 years after Larson develops the formula, the company packages WD-40 in aerosol cans and begins selling it directly to consumers through retail channels in San Diego. The retail launch is not accompanied by a significant advertising campaign or a sophisticated marketing strategy. It is accompanied by the product itself, which performs visibly and immediately on every application, which means every person who buys it tells the person next to them what it did. Word of mouth at industrial scale. In 1969, the Rocket Chemical Company acknowledges the commercial reality of what it has built and renames itself the WD-40 Company. The single product has consumed the entire corporate identity. The decision not to patent the formula deserves specific attention because it is the decision that defines the company's competitive position for the next 7 decades. A patent provides legal protection against copying, but requires public disclosure of the protected formula or process. Once a patent expires, typically after 20 years, the formula becomes public domain, and any competitor can manufacture an identical product. The WD-40 Company calculates, correctly, that trade secret protection is more durable than patent protection. If no one outside the company knows the exact formula, no competitor can replicate it precisely, and no expiration date threatens the exclusivity. The formula goes into a vault. The vault stays closed. Competitors produce similar water-displacing penetrating oils under names like PB Blaster and Liquid Wrench, and they compete on price and availability, but they cannot produce the identical product because they do not know what it contains. This is an unusual strategy for an unusual company. The WD-40 Company at its core is not a manufacturer. It outsources the production of WD-40 to contract manufacturers who receive the formula under strict confidentiality agreements and produce the compound to specification. The company's primary functions are brand management, distribution, and marketing. It employs a relatively small number of people for a company of its revenue scale. The asset is the formula and the brand, and both are protected by secrecy rather than by legal instrument. The company goes public in 1973 and lists on the NASDAQ exchange. Its financial profile is unlike almost any other consumer products company. It is a single product, sold in over 176 countries, with a gross margin that reflects the brand premium built over decades of market presence. The company does acquire additional brands over time, including 3-in-1 oil, a penetrating oil brand with its own established consumer following. But WD-40, the product, remains the center of gravity around which everything else orbits. The Atlas missile, for which the formula was developed, flew for the first time in 1957 and became the rocket that carried John Glenn into orbit around the Earth in 1962 as part of the Mercury program. The missile that needed WD-40 to survive on the launch pad became the vehicle that put an American astronaut into space. The product developed to protect it became the most common spray can in the world. Neither outcome was anticipated when Norm Larsen sat down to attempt his first formula in 1953. The formula he eventually produced is not magic. It is chemistry, specifically a blend of lubricating oils, a penetrating solvent, and a propellant, combined in proportions that optimize performance across a wide range of applications without excelling at any single one. This is the central truth about WD-40 that its devotees and its critics agree on equally. It is not the best lubricant. It is not the best rust remover. It is not the best water displacer. It is a competent performer across all of those functions in a single package, available everywhere, instantly recognizable, and cheap enough to use without hesitation. That combination turns out to be more valuable than excellence at any one thing. Somewhere today, a plumber in Glasgow crouches under a kitchen sink, reaches into a cabinet for the blue and yellow can he keeps in every van he drives, and sprays the base of a corroded shutoff valve that has not moved in 23 years. He waits 30 seconds. He applies the wrench. The valve turns. He replaces the part, closes the cabinet, and moves on to the next call. He does not think about Norm Larsen. He does not think about the Atlas missile or the Convair Corporation or a San Diego laboratory in 1953. He thinks about the next job on the list. He puts the can back in the cabinet. He will need it again before the week is out.